Hello, dear. By the way, for this video, in this video, we'll begin to run through the algorithm for the quadratic probing hashing, how it will be calculated. So suppose that we do have m is equals to 10 as well. So for this one right now, since this is the formula they'll begin to base, and this is the quadratic probing formula they'll begin to base then, and be reminded that the I, since that is index plus I, then squared, and so on. So of course, we'll begin to deal on that later on accordingly on how to work on that. So let's try to run through with this here. Suppose that your index is you will begin to have a index 0, index 1, index 2 for the table up until 9 for the tracking. Now, according to this one, what we'll begin to run through, we'll just have to calculate this properly. So how can we do it? Let's try to run through the insert 44. How can we insert 44? So 44 will be calculated the same thing with the same manner that we'll begin to calculate earlier. So for this 144, calculating over 10 will be um, 44 divide 10 is um 4, then 4 times 4, 10 equals 40. 40 minus 44 is 4. So the um the modulo of 44 base of 10 is actually 4. That is the remainder that you do have. So checking the your index number 4, if it is empty, so of course empty. So you just have to make sure that insert 44 right there. So 4 will be located here then. 44 rather. Now, we're done with the 44. Let's run through the second key. 94 is our key right now. 94 modulo of 10, of course, 94 divided by 10 is 9. 9 times 10 equals 90. 90 minus 94 is 4. So therefore, 4 is your modulo remainder. So index 4 is taken. So therefore, this is array based and we cannot take that over again. So what will gonna happen? We will deal with the data collision handling. For this one right now, index. Okay, we'll use this formula. So what is the index that we do have right now? So it will become 4 plus I. So this is the first data collision happen. So therefore, begin with 1 squared. So 4 plus, you have to work on with the 1 squared. That is 1 times 1. So 1 times 1 equals 1 still, diba? And then equals 5. So therefore, checking index 5 um, equals empty. And of course, we can allocate there the 94. So index 5 equals 94. Now, we are done with that one. Insert na naman again this 64. Insert 64. 64 modulo of 10. So 64 divided by 10. So therefore, what you will need to do, it will become 6 times 10, 60, 60 minus 64 equals 4 still. So index number 4, checking the index number 4, that is taken earlier. So since that is data collision, so of course you're now in index 4 plus 1 squared, since this is the first handling of the data collision. So, for pila ang 1 squared, that is 1 times 1, so still 1. Then, that is 5. So, index number 5, it is actually taken. So what will gonna happen? We will be going to still 4 index 4 earlier. You will begin to matter in that one. 4, then this is how this is for how many data collision already. This is for the second data collision handling. So that it will become 2 because this is the matter from 1, it will become 2 and so on and so forth. So forth. Now 2 squared, excuse me. Now 2 squared is 2 times 2, that is 4. So 4 plus 4, it will become 8. So therefore, checking index number 8, if it is empty, so let me just make it low because my eyes is having index 8 is empty. So therefore, um we can allocate 64 here. Okay, 64. Now we're done with the 64. Let's try to run through the 74. Insert 74. Now, 74 modulo of 10. 74 divide 10, that is 7. 7 times 10 equals 70 minus 74, that is 4. So, index number 4, that is taken. And what can we do? That is, index is 4 plus 1 squared because this is the first data collision. So 4 plus 1 equals 5. So therefore, index number um, 5 is also taken earlier. So this is the second data collision, 4 plus 2 squared. So it will become 4 plus 4 and it will become 8. And index 8 is already allocated also. What can we do? It will become 4 plus 3 squared. So equals 3 times 3, okay? 4 plus 9. So 9 plus 4, that is 13. So since 13 is beyond the 9 limit, 0 to 9. So you have to check 13, 10, and that is remainder 13 divide 10, that is 1. 1 times 10 equals 10 minus 3 equals 13 minus 10 minus 13 equals 3, remainder 3. So therefore, check index number 3. So in your index number 3 right now, that is empty. So therefore, we can just allocate 74 right there. So 74 in your index 3. So we're done with 74. Let's proceed with 18. So insert 18. So right now, 18 modulo of 10, that is 1. 18 divided 10 equals 1. 1 times 10 equals 10. 10 minus 18 equals 8. So therefore, index number 8, that was already taken. So just have to 8 plus 1 squared because this is the first data collision. So therefore, 8 plus 1, 1 times 1 for the squared. So that is 1 still. So 9. So index 9. Checking index 9 if it is empty or not. So index 9 is empty. So therefore, we can just allocate 18 right there. Now, 18 will be stored in your index 9. So we're done with this one. So we'll proceed with 28. So insert 28. Now for 28, modulo of 10. And so therefore, 28 divide 10, that is 2. 2 times 10 equals 20. 20 minus 20, minus 8 equals 8. So therefore, modulo is 8. So checking index number 8, that is taken already. So what will gonna happen? You just have to probe 8 plus 1 squared equals 8 plus 1 still because 1 squared equals 1 and that is 9. Index 9 is already taken. So index 9 is taken. What can we do? It will become 8 plus 2 squared because this is for the second time around. So 8 plus 4, that is 12, right? So 12. So since that is 12, 12 over modulo of 10 equals 12 divide 10 equals 1. 1 times 10 equals 10. 10 minus 12 equals 2. So therefore, index number 2, check number 2 if it is allocated or not. So I'm so sorry. Um, just went up. So by checking the index number 2 as what we do have in index number 2, that is empty. So therefore we can just simply, so sorry, the pen is not being changed. So index 2 is empty. So therefore we can just simply allocate 28 in index 2. Now, afterwards we'll insert 30. Insert 30. So insert 30, 30 modulo of 10. So that is 30 divide 10, that is 3. 3 times 10 equals 30. 30 times 30 minus 30 equals 0. So 0 is the modulo. So index 0, if it is, so index 0, that is empty. So therefore, we can just simply allocate 30. So allocate 30 here. So this is the details um of your data earlier. 44 has been stored here, and 94 has been stored, 64 has been stored, 74 has been stored, 18 has been stored, and 28 has been stored, and 30 has been stored. So that is this one is empty. This one is empty. Empty. By the way, there will be such instances in your quadratic probing that it will gonna loop. So say for example that the answer right now will be there's instances actually that it will keep on looping over and over again. So say for example that if you will calculate 8 plus 3 squared, it will become 3 times 3 equals 9. 8 plus 9, that is 17, correct? So it will become 17 modulo of 10, it will become 7. So look, check 7. Afterwards, if it is, if 7, if it's taken, we can just simply 8 plus 4 na naman squared. Then it will become 8 plus 4 times 16. 16 plus 8 will become 24. So 24 modulo of 10, it will become 4. So there will be such instances nga it will keep on looping with the same number. So let me try out if there will be such instances like that. 8 plus 5 squared, for example, and then 8 plus 25, 25 plus 8 equals 32, 32 modulo of 10 equals 2. So this is what I mean. So next 2 and next 2. So this is a loop already. If it is a linear, if it is gonna happen, you just have to run through if 2 earlier is there, so 2 here already the second time around. Once you will be going to check in your 8 plus 6 squared, 6 times 6 is equals to 36. 36 plus 8 will become 44. So 44 will become modulo of 10 will become 4. So this is another loop because let's try to see. This is the loop earlier, 4 and 4. So if this will be the case that um 2 and 4 and 2 and 4, you can see that one twice, at least twice. You just have to stop. So you can just say that the probing for quadratic is keep on looping with the same number, and we cannot allocate and into any other hash table number or index. Okay, so you just have to provide an explanation why it will not be allocated in different number. Okay, I hope so that it is clear for everybody. So see you in the next video for the double hashing. I will not be going to run through with the searching for this because it will be the same thing with this searching of other hashing because we don't have much of time. But for searching, you have to do the calculation, the same thing, and then we'll just locate if that is located right there and so on. If I do have a time, I will just have to run through with that.